My name is Margie Brenner, and I work at the Wind Energy Center at University of Massachusetts Amherst. Today, I'm speaking with Sanjay Arwade. He's a professor of civil engineering at the University of Massachusetts Amherst and associate director of the Wind Energy Center. Professor Arwade studied structural engineering and mechanics at Princeton and Cornell universities and works primarily in areas of probabilistic mechanics, offshore wind energy engineering, and reliability. His work has been funded by the U.S. National Science Foundation, BOEM, and the Massachusetts Clean Energy Center and industry.
Well, I grew up around engineering. I grew up in Manhattan in New York City. And so life in New York City is surrounded by all kinds of engineering, particularly structural engineering. And that's the field I was first drawn to, both by my experience as a child around New York and with my father, who was a structural engineer. And also by an experience at college, where in the second semester of my first year, I took a course actually on the history of structural engineering and structural design that I found really inspiring, particularly in the way that Professor David Billington, the instructor of that course, described engineering as being a fundamentally creative discipline. And I think that's something that's often lost, the idea of creativity in engineering. People sometimes think of engineering as a calculating activity, which it is, but it's also fundamentally a design activity, and engineering design can be just as creative as architectural design, as sculptural design, as musical design. So in terms of engineering as a discipline, I think that's how I wound up there. And then I was lucky enough to be invited to join the faculty here at UMass in 2006. And quickly got excited about the work being done in the Wind Energy Center. That was right around the time when the wind industry was beginning to turn its vision offshore. And it so happened that the structural and reliability challenges faced in offshore wind engineering are substantially greater, more difficult, and more interesting than those faced for onshore wind installations. So I think that's what really allowed me to get excited about offshore wind energy engineering, the timing of my arrival here at UMass, and the, of course, existing expertise in the Wind Energy Center here. Well, I've historically taught a variety of kind of core engineering mechanics courses at the graduate and undergraduate levels. But what I'm most excited about right now, and it's going on at this very moment, is a new course I'm offering in offshore structures. And this will be the first course taught in offshore kind of structural engineering, possibly since the time of William Hieronymus. I don't know if we ever actually taught such a course. But historically, the focus of the Wind Energy Center has been on the machine, the energy generating machine. And in research, we as a center have significantly broadened our interests to support structures, foundations, and then, of course, environmental and political, social impacts as well. But our teaching is now sort of catching up with our research. Professor Sharman is teaching courses on offshore renewables and waves. And with this new course on offshore structures, I'm hoping to contribute to that. So we're going to cover everything from environmental condition assessment, winds and waves, through to the design of fixed and floating support structures, and some reliability concepts and some geotechnical and geophysical concepts as well. And I think my hope is that we'll be able to send students out with a pretty good base in being able to think about the design of offshore structures for renewable energy. I think the really unique thing about being a professor at a university is getting to see students come through and then go out and do things in the world, right? I mean, we're unusual as university instructors in that we have this kind of constantly rotating crop of students that we're getting to educate and mentor, and then see them go out into the world and do great things. So it's always particularly satisfying when you hear from a student 3, 5, 10 years after graduation and get caught up on what they've been up to out in the world of engineering design. More specifically, it's been very exciting to be part of an area of research and education that is having such a big potential impact on the country and the planet. And I'd say that's unlike things I've done before in my career as a researcher and educator, that it's by far the sort of research and education topic that is meeting the most pressing need of society. And I think to begin to see some of our work and results start to trickle out to have an influence in industry has been really satisfying. A lot of my offshore wind research right now is focused on new concepts for mooring systems for floating offshore wind. And I think that's exciting for a number of reasons. First of all, good solutions to the problem of floating offshore wind have the potential to open up huge new areas of the ocean to clean energy generation. In the United States, you think particularly about the West Coast and the Hawaiian Islands, right? But also certainly along the coast of East Asia and the Western Pacific, potentially coasts of Africa and so on. So, looking at these floating systems, I think is really exciting. And I think it's an area where academic researchers have kind of more of an opportunity to contribute because the industry is not quite as mature as it is for fixed bottom solutions. So generally speaking, floating, more specifically, we've been looking at this concept of trying to share anchors amongst multiple floating platforms and thereby potentially reduce the number of anchor installations that are required for a floating wind farm by as much as 2/3, which would be huge, not just in the amount of steel that needs to be sunk to the bottom of the ocean, but also in the very expensive vessel days that are required for installation. So that's been a really fun problem to look at, and it brings together the complex dynamics of the floating platforms with the complicated soil structure interaction that goes on at the anchor, and then some really interesting kind of reliability and failure mechanism problems that come up when you effectively knit an entire wind farm together through this system of shared anchors. Well, I think in the short term, if we think a couple of years, right, I think it's critically important that the currently permitted projects get built. I think that once we have some full commercial scale wind farms operating off the coast, I think the level of acceptance will rise very, very quickly, and that society will begin to understand the benefits of having this clean energy fed into the grid. I think it's really important, if we're going to achieve excellence in offshore wind, that we see increased partnerships between universities, government, and industry. We've already started to build many of those relationships here at UMass Amherst. Many of them are longstanding. A lot of the floating research that I was talking about a few minutes ago involves industry partners from across the country and world, and government partners from within the state, from within the region, and nationally as well. So I think continuing to build and develop those partnerships is absolutely critical. And the reason I say that is because we're talking about erecting tens of thousands of structures and turbines in the oceans if we're going to meet our national renewable energy goals, and the associated transmission infrastructure, operations and maintenance infrastructure. What we're talking about is building a huge new civil infrastructure system from scratch. And we haven't really done that. I mean, maybe the interstate highway system one could point to, but even in comparison to that, the time frame over which we're hoping to do this offshore wind development is much, much shorter, and the complexity is greater than a network of roads. When you look at the complexity of the wind, the energy generating machine, the support structure, the substations, the export cables, it's an infrastructure system that brings together so many different disciplines that I think it's both a great opportunity and a sort of project that poses a lot of pitfalls potentially. So we need to do it right. And I think these government, industry, academic partnerships are the right way to make sure that we do it right and deliver maximum benefits to society.